Hello, my name is Michel Pahu and I work for Microsoft Research University Relations, and I'm going to show you an innovation that I created in collaboration with Microsoft Research Natural Language Processing Group. This innovation actually allows to convert text to animation in the virtual world as well as in the real world with robotics. The main goal of this innovation is to motivate kids to write natural language so they have an instant reward. And this innovation is going to be incubated with a project named KidTab in the Advanced Strategy Group. This tool is named StoryBuilder, and basically what I'm going to show you is just the engine of that. So there is no user interface or usability studied or anything. Okay, so basically let's suppose that I'm writing once upon a time a dragon flew over a beach. Then the natural language processor basically takes this statement and extract the information about, okay, who is the actor, what is the action, where is the action performed, on what the action is applied, and so on. And then the graphics, the animation engine is taking this information and then generating the animation on the fly using a database of objects, animations, and so on. Okay, so let's say, so I'm just writing once upon a time a dragon flew over a beach. Then as soon as I type the period, I get the corresponding animation. So let's suppose now I type then it fell down. Then I have an instant reward and see the dragon falling down. Okay, so now let's suppose that I want to sketch an actor. So I click on sketch. And that's very good for extensibility, so I can have any type of actors and I could create my own custom actor. Right now I just allows to implement the head of the actor, so draw or use pictures to create the head of the actor. But then you can imagine more than that and also have animals and so on. So let's suppose now I just take a picture and I put that at the head of the actor, and the body will be able to perform all the actions that are supported. So now, if I, for instance, I could also sketch on it, so I could draw something on the top of the head, and so on. Okay, so here I use a picture of my face, for instance, and now I choose a name for the actor. So let's say I will put my name, and also, by the way, while I'm creating a new actor for my story, I can also construct the head with paper. So if I click here, I can get something that I can print, and then I can create with origami an actor such as this one, for instance. So kids could, for instance, print that, fold it, and then get an actor. On the top of that, on the head, there is some text that they have to read, and also on the back of it, there is some text. And there is also a barcode, so then in the future we could also have kids exchanging their actors. And of course behind the scene there would be a network such as Conference XP, for instance, that would take this information and exchange between computers. But the barcode would be a physical way to exchange objects between kids. Okay, so but let's not go there. So now let's say I just sketch my new actor, and now I have the name, so I have my new actor. And now I wanted to write the statement about that, so I write, for instance, finally Michel kicked the dragon, and I type a period, and now I have an instant reward with the new actor that I just created. So that allows you to create a lot of new actors and personalize your stories. And at the same time, we bypass a limitation because we cannot have that many actors, and because all the actions needs to be known ahead of time. Here you just sketch the head and you get a body that is able to perform everything. So, and also we have the same for like woman, boy, girl, and so on. So this is really extensible, and we could go to animals. So now let's suppose that I write, then he ate a pizza in the town. So in the database, I don't have the pizza, and I did that in purpose here. And now we want to see how this tool can scale. So if I write that, obviously, since I don't have the pizza in the database, I cannot generate the graphics or the animation, the corresponding animation. So if I write that, now I have a pre-animation checker that will see, okay, there is no graphics for the pizza, so now I need to ask the user to draw a pizza. And since KidTab is based on tablet PC, it's a good opportunity to use tablet PC to draw objects that are missing. And it's a way to scale with all the missing objects. Why don't we ask kids in order to draw those objects? So also we realize during sessions with kids that actually they really like to teach the computer. So actually this limitation becomes an opportunity since kids like to teach the computer and draw new objects. It's very good to have that and ask them to increase the number of objects into the database. So now it automatically opens on the dialog box with the pizza word and say, okay, can you draw it for me? So I will draw a pizza. And let's put some pepperonis on it. You want some mushrooms? Okay. Et voilà, with a French accent, of course. And so now that I have the pizza, I can click OK, and I will get the corresponding animation with the man eating the pizza. So that's a way to scale. And now, for instance, if I write another statement like Michel kicked a pizza in the forest, it will reuse the same object, and this object will, for instance, in that case, have the parabolic trajectory given the fact that it has been kicked. So let's try that. If I type a period here, now I see the animation actually even with the shadow of the object flying. Okay? So that gives you an example on how we could scale when an object is missing. This tool can be used by kids in order to learn how to write. So for instance, they write a story and they get an instant reward. But also, in addition of that, you can imagine that parents could use this tool as an authoring tool. So they write a story, and then once the story is done, ask kids to read this story back to them. So let me show you an example of something we can do. So now we just wrote a story, and now I have another tool that uses speech technology that will display all the statements we wrote and ask the kids to read. And as they read the statements, the previous animation that was generated will be played back to the kids as an instant reward of their reading. So for instance, here I have the first statement we wrote before. Once upon a time, a dragon flew over a beach. So let's read that to the computer to get the first animation. So I click on read. And again, there is no user interface, anything. Once upon a time, a dragon flew over a beach. And now I get the animation, the corresponding animation. Then it fell down. Now we can see the dragon falling down. And now I have the last statement to read. Finally, Michel kicked the dragon. Finally, Michel kicked the dragon. I get the animation, and so on. So I can read my story back, and you could imagine I have a big screen and display that on the wall and so on, and have something very fun for kids. So during night, for instance, they can read story back to their parent and so on, and have personalized items, face of family people, their toys in it and so on. So that can be very powerful.